this question is testing whether you can convert a wavelength of a photon into an energy and make conversions between electron volts and joules. It's also testing that you have a good understanding of the work function and how the kinetic energy of photoelectrons released in the photoelectric effect, how the maximum kinetic energy depends on the incident photon energy and the work function. So the maximum KE, so KE max, is the energy available from incident photons, which is HF. Take away the work functions, the cost to liberate those electrons from the metal. So we've got the energy left over, effectively kinetic energy left over from liberating the electrons from the metal, is equal to how much energy you had available from the photon, take away how much it costs to get out. And hopefully that makes sense. We're not told frequency, we're told wavelength. So C is F lambda, so F is C over lambda, and you'll end up with HC over lambda, take away the work function. Now, in all of this, we've got a mix of EV and photons. So what I might do is I might calculate this separately, so calculate the energy of the incident photons separately in EV first, and then it's a much more straightforward calculation. Otherwise, it might get a bit messy and confusing. And what you want to be avoiding at all times in an exam is being messy and confusing. So the energy of the available photons, the energy available from the photon, 6.63 times 10 to the negative 34 Planck's constant multiplied by the speed of light, 3 times 10 to the 8, all divided by this 290 times 10 to the negative 9. And we'll work that out, we'll calculate that and get what that is in, it's going to be in joules. So 6.63 times 10 to the negative 34 times 3 times 10 to the 8, all divided by 290 times 10 to the negative 9, will give me 6.86 times 10 to the negative 19 joules. If I then divide that by the charge of an electron, so joules is a huge measurement of energy, and electron volt is tiny by comparison. So I need to be dividing by 1.62 because I should end up with a much bigger number of electron volts than I have of joules. So we'll divide that by 1.6 times 10 to the negative 19. It's going to be about 4. And it's 4.29. So we end up with 4.29 EV. So the energy available is 4.929 EV, and that's actually one of the answers given, but that's not the right answer because we need to subtract the work function. So the work function is about 4.1. So the maximum KE in EV is 4.29. How much was available? Take away 4.1, and we end up with about 0.19 EV, which is answer A.